Welcome back for another video in our series on basic Python programming. Today's topic is plotting in Python, and in particular with a focus on Matplotlib. The materials for this video are presented in Chapter 3 of our Jupyter Notebook series. Please load plotting using MATLAB in your Jupyter Notebook. I again recommend to go restart the kernel and clear all output for the best interactive experience. Make sure you have trusted activated. So, what is Matplotlib? Matplotlib is an extension to Python that implements most of the 2D and some of the 3D plotting capabilities known from MATLAB for Python. The nice thing of this library is that it really behaves very much like you're familiar with from MATLAB. And even if you're not familiar with MATLAB plotting, you will figure out it is surprisingly simple to implement, surprisingly simple to work with. So before I go into any bit of programming, I want to point you here to that link that is the Matplotlib documentation and their gallery. If we jump to this one first, this is the perfect way of starting. You know what you want to plot. They provide us with a beautiful gallery of example plots. Any bit of example plot that you need, you look which one's the closest to what you want. Once you have something that is close to what you actually want, you go there. You have the example, and you have a fully functioning Python code. So you can pretty much copy and paste and then start working off that code. I love their documentation. It saved me so much time trying to learn it, try to find things. What I'm doing with you today is I just want to give you a quick intro to say what are the key features, because it's really not very hard, and get you going. So let's start. First, Matplotlib behind the scenes uses the array data type that we discussed in the previous section to represent its data to do its computations that it needs to get you the plots. So we typically need to provide data type as Matplotlib as NumPy arrays. And so I need NumPy. And the second one, that's something for most of our needs, works the same way. Matplotlib has a lot of functions, but it provides through the pyplot package a very neat, very simple to use interface. So what we do in most of the applications, we do import matplotlib.pyplot. And since it's really painful to type matplotlib.pyplot all the time, we do as well an alias and call it PLT. PLT is recommended by Matplotlib for a short for plot. So let's just do and plot trigonometric functions as a quick start. First, we need a set of data points that provides data points to plot on the x-axis. And how about we make evenly spaced x numbers from 0 to 2 pi 100 points. And that works again similar to what you may be familiar with MATLAB, but it's provided by the NumPy package. There's a linspace operation that says, give me from 0 to 2, and the number pi, NumPy has the constant in it. So it's numpy.pi and give 100 points. This is similar to range. There is an arange function that creates it immediately as an array, but range gives in intervals, in given intervals, while the linspace says take an interval and break it into that many points. So it's for plotting typically the linspace a bit easier. Then there are sine and cosine functions in in Python, but those functions, they only act on a single number, on a single floating point. If you use instead numpy sine or numpy cosine, you can give an array object and it creates an array that has the sine or cosine computed for every element in there. So fully vectorized makes it very easy. Again, numpy is the magic thing, and BLT is our plotter. So if we say from the plotting package, use the plot function, set of x values, set of y values, and that would already do it, but I give the extra option, and that option works exactly as in MATLAB, where I say, give me a solid line and use the color red. Let's try that. And it only works if I load the library. So I did not execute the rest. That's why I got an error. I had to re-execute or execute that stuff to simply create my figure. Very easy. I got the X, the Y values, everything else taken care of. If I want to plot that instead, the cosine function, and I use a blue dashed line, here we go. The behavior here is, again, for my MATLAB users, a bit different. You've seen, if you use Jupyter notebooks, then every cell starts a new figure. If you have that written in a file, it doesn't, then it's more like an automatic plot hold. If you want more than one figure in one picture, the way to do it is simply to combine them in one cell. So I've combined the two. This is my red sine, that's my dash blue cosine, and I turn on the grid. So the plotter has the grid, and it's a bit different from the MATLAB one, where here we just have a function with the argument true or false. So if you want to turn off the grid, it's the argument's false. And if you check the manual, then you will see that you can fire it up with 2 arguments to get secondary grid. So let's try this. Now we see we plotted the red sine, the dash blue cosine function, and we added a grid. That's nice to work in a notebook. What we typically do, we are in academia, we want to publish, we want to put our figures in a nice file. So the figures need to be pretty, the figures need to be exported so we can put them in our paper. There is a pretty easy function to use, and that's plot has a save fig. So all you do is first you plot, you do your normal plot. And the last thing is plot save fig, and you provide the file name. The file name itself, all you have to do is give the proper extension, and that's the format in which you get it. So PNG is a bitmap. PDF gives you a nice vector graphic. And while most of you know JPEG, never use JPEG for a line graphic that looks like you have a smeared line. PNG, GIF, TIFF, for bitmap formats, give the best quality for publications. Best is PDF because it's scalable. Unless you're on Microsoft Word, then sorry, you need to use, ideally for line graphics, use a PNG and check the manual page. There are options to get a higher resolution, so you get it for your publication. The other thing, you have things like legend, title, etc., intuitive from MATLAB, but it's a little bit different from MATLAB. So you see your labels go with the plot. The legend doesn't provide that. If you want to see all those examples, again, please check out the manual page. But basically what I've done here, I created the figure, it shows it to me here. That's the figure I did. I added the tangent function, set the limit, put the legend, everything. And if you check in the folder where you have all your notebooks, that should have created a PNG. If you click on this, it just loads it. So that's the figure that we created. I enlarge this now, and you see that it's quite pixelated in the fonts. That's because it's a PNG, it's a bitmap thing. It doesn't scale very well, and that doesn't make us happy for normal publications. And I am not completely sure if I remember the command right. It looks like it may have been that one. Yep. So I gave it a higher quality, and you see I just recreated that figure at a much higher rate, a much higher pixel density. I normally don't do it to go that high, only for publication purposes, because for research purposes, or if I want to make a video, I want them to be quick to load, like I'm back to my small one, quick to load and cheap on my hard drive. So I only create figures that I need high resolution. So at that point, that was a very, very quick crash course introduction, but the exercises will force you to review a little bit more of the gallery and find how to do much more. It's a very powerful tool, and we're going to get back to this also throughout the following sessions.